Taking a closer look at the LJ Create Electric Vehicle Systems Panel Trainer. Our electric vehicle trainer is designed to accomplish three things. Number 1. Keep people safe. Demonstrate how to work safely on an EV. Number 2. Illustrate how the EV system operates. Number 3. Demonstrate how to fix the EV system when it goes wrong.
Taking a closer look at how the panel is designed to keep people safe and demonstrate how to work safely on an EV.
The panel operates at scale voltages that are completely safe for the users. This means that inexperienced learners can be left to use the trainer unsupervised. Instruction starts with an investigation of the service disconnect, the first responder loop, and the HVIL safety systems. Investigating the service disconnect. Connect the multimeter to measure the 12 volts on the HVIL loop, and the 400 volts at the HV distribution contactor outputs. When the service disconnect plug is loosened to its first position, the voltage on the HVIL loop reduces to 0 volts. This causes the HV distribution contactors to de-energize so that their contacts disconnect the HV battery, and the electric vehicle's circuits decay from 400 volts to 0 volts. The hazardous voltage has been removed from all of the EV circuits. At this stage there is still 400 volts at the HV battery terminals. When the service disconnect plug is fully removed, it creates an open circuit in the battery, and removes the HV battery voltage from its terminals. Investigating the first responder loop. Observe the voltage dropping from 12 to 0 volts when the first responder loop is disconnected.
Taking a closer look at how the EV system operates.
To switch on and drive, insert the key fob. Disconnect the charging input. Apply the brake and press the start button. To select transmission, apply brake and adjust shift control knob. Apply the accelerator to drive the vehicle. Power flows from the battery to the wheels, via the power electronics module, traction motor, transmission and drive shafts. Apply the brake to demonstrate regen power flow. The major electrical blocks of the EV system are represented on the panel. Voltages and signals illustrate the way in which the blocks interact during operation of the electric vehicle. Learners can monitor the three-phase signals that are generated by the power electronics module that are applied to the electric vehicle traction motor. Learners can also monitor the high-speed CAN bus signals that are connected to all major electrical blocks. Investigating the charging system. Select AC or DC charging. Start the charging session. The onboard charger converts AC input to DC, to charge the HV battery. The DC output voltage from the onboard charger can be measured, to see the HV battery increasing as it is charged. Alternatively, if DC charging is selected, the display shows a much faster charge cycle than with AC charging. For DC charging, the DC voltage into the charge port is applied directly to the HV battery. The panel shows whether AC charging or DC charging is occurring, by indicating which HV charge contactors are closed. Learners can change the charge parameters, by altering the level of the HV battery charge. and adjusting the temperature of the HV battery. Modifying the HV battery temperature will activate either the PTC heater or the AC compressor, as the system works to maintain the ideal temperature of the HV battery.
Taking a closer look at how to fix the EV system when it goes wrong.
Instructors have a passcode to open the fault insertion panel. There are two fault insertion modes. Single session mode requires the password to be entered each time the fault insertion screen is accessed. This is ideal for instructors, to lock in a fault for learner assessment. Alternatively, once the multi-session mode is set, the learner can access the fault insertion screen for the period of time the panel remains switched on. "16 faults are available, covering all blocks of the EV drive and charging system." The fault insertion panel provides optional descriptions of each fault. Multiple faults can be inserted at the same time. The troubleshooting process starts with the virtual scan tool. If the system has multiple problems, the codes are listed so that the learner can step through them. Learners then turn to a multimeter, or scope, to confirm the faulty component. Following a period of learner practice, instructors can insert a few faults, lock the insertion panel, then leave the learner to list out the faulty components as an authentic assessment activity. If you have received your panel, we're here to help you integrate it into your program. If you would like to order a panel, please contact us for more information.